With quarantine going on, everybody's probably feeling something bringing them down. But we're not going to talk about our emotional state. Rather, we're going to talk about a physical force that brings everybody down: gravity. Our first belief that there was some sort of force bringing us down began in the early 1500s with Greek philosophers such as Galileo, Brahe, and Kepler. They determined that the Earth and other planets orbited the Sun, as seen in our heliocentric model, sorry Ptolemy, and that the Sun must be enacting some sort of force on the planets to keep them in orbit. However, Kepler discovered that the planets orbited in an elliptical pattern and not in a perfect circle. The big question was, why? Well, let's fast forward to see where we get those answers. In 1687, Sir Isaac Newton developed his comprehensive theory of gravity. As the story goes, Newton was sitting under an apple tree when an apple fell into his head, causing him to make the realization of gravity. Now, this story may not be true, but it is the idea of objects falling that gave Newton the idea that there must be some sort of force at work. According to his first law of motion, which he wouldn't publish for another 20 years, every object will remain at rest or in uniform motion in a straight line unless compelled to change its state by the action of an external force. Therefore, if an object were to fall from a tree to the ground, there must be some sort of force causing this change from rest. Newton called this force gravity. Newton went on to develop this equation to explain that the gravitational force being enacted between two bodies was directly proportional to the product of the mass of the two bodies and inversely proportional to the square of the distance between the center of the two bodies. This whole equation, however, has to be multiplied by what Newton called the gravitational constant, G. This constant is valued at 6.674 times 10 to the negative 11th meters cubed per kilogram second squared. Newton's theory was revolutionary as it helped prove the ideas of earlier astronomers. However, it still left us with the question of, what is gravity? Let's fast forward again. From 1907 to 1915, Albert Einstein developed his theory of general relativity. As it pertains to gravity, Einstein theorized that the observed gravitational attraction between two bodies is a result of the warping of space and time by those masses. We'll use a visual to help demonstrate. For our purposes, this blanket will represent the plane of space and time. Notice when no object exists on it, the plane remains straight. However, when an object of large mass exists in it, the plane begins to warp. This warping will cause smaller objects, such as this ping pong ball, to be attracted to the larger bodies. Therefore, the larger the mass of a body, the larger gravitational force it will enact on another body. This is why, on Earth, if I weighed only 100 kilograms, I would weigh approximately 16.5 kilograms on the Moon, because the Earth has a much larger mass. Thanks for watching, and I hope this video helped.